Hello children, how are you all? Hope so you are doing good. Yes, in the today's session we are going to start a playlist on the concept circles. The concept belongs to class 10 ICSE, wherein we are going to solve many exercises and many problems from the concise mathematics, that is Selina publications, and also we are solving the previous year questions from the topic circles. So let's not delay children. Once again, welcome you all to my channel, that is Ignite Math ARP. Don't forget to subscribe, like and share among your friends. So let's start the concept children. Circle and its parts. First thing we are going to learn, it's a very basic thing what actually you all learned in your previous lower classes. Now let me define circles. A circle is a shape consisting of all points in a plane that are at a given distance from a given point. That point is called as center. Now I'd like to show you a figure over here. See children, I have given you a different parameters of the circles over here. You just, for the introduction, you need to go through it. You already how you have learned all these things in your lower classes. Correct children. So now let me speak about the point that is called as a center. What is a center? It is nothing but the fixed point from which all the points on the circumference, that is nothing but the boundary of the circle, are at equal distance. What is that equal distance? That is nothing but the radius. The distance between the center of the circle and any point on the circumference is called as a radius. Clear children? So whenever a line segment is drawn connecting any two points on the circumference, we are going to call that as a chord. Chord divides the circle into two different parts, and each of them are called as segments. If it is the smaller one, it is called as the minor segment, and if it is the bigger one, it is called as the major segment. Clear children? When the chord is drawn such a way that it is passing through the center, it is called as a diameter. Clear? So diameter is the longest chord of the circle. You need to understand children, this is nothing but the longest chord of the circle which divides the circle into two equal parts, and each of them are called as a semicircles. Okay children, okay, they are called as semicircles, two equal parts of the circle. Clear? Right? So now whenever two radii, radius is a singular, radii is plural. Whenever two radii are drawn, see this is one radius and this is one radius. Whenever two radii are drawn and which is embedded by, which is bounded by the radius, this area is called as sector. Sector of the circle is nothing but the area between two radii and an arc. Then the question arises, what is arc? Arc is nothing but the part of the circumference is called as arc. Clear children? Right. So now I'll just discuss on the definition of the tangent, but on the tangent and secant properties we are going to discuss in detail in the other chapter, that is secant and tangent properties. Tangent is a line which is passing through single point on the circumference. Clear children? This is called as a tangent, and the secant is again a line which cuts the circle at two distinct points. This is called as a secant. Is that clear children? I hope so. All the elements of the circles, all the parameters of the circles are clear to you. Now let us discuss on some of the very important things what actually we discuss in our lower classes, that is ninth standard. Now let us study what actually we have learned in our ninth standard as previous knowledge. Right children? So we learned that a straight line drawn from the center of the circle to bisect a chord which is not a diameter is right angles to the chord. In the sense, I just make it so clear children. If I have drawn a bisector from the center of the circle to the chord, okay, so if I'm taking AB is a chord, OP is a bisector drawn from the center of the circle to the chord, and it is going to be right angle to the chord AB. In the sense, if AP is equal to BP, then I can say OP is perpendicular to AB. Very clear children, very simple, right? So now let us see the second point. The perpendicular to a chord from the center of the circle bisects the chord. It is just the reverse and the converse case of the previous one. Here I am drawing a perpendicular from the center to the chord. If AB is the chord, here in the beginning itself I know that OP is perpendicular to AB. Then AP is going to be PB. Clear, children? If OP is perpendicular to AB, then AP is going to be equal to BP. A bisector is perpendicular and a perpendicular is bisector. Very simple, very simple, right? So now next point is equal chords of a circle are equidistant from the center. Clear? So what is the meaning of this statement? So now if a circle, in a circle, if I have two chords, look at this, AB is a chord and CD is another chord. Clear? Okay, so now if the chord AB is equal to chord CD, then whenever I'm talking about the distance of the chord from the center, I'm talking about the perpendicular distance of the chord from the center. If O is the center, distance of the chord from the center in the sense perpendicular distance of the chord from the center. Clear, children? Right. So if two chords are equal in length, they are at equidistance from the center. So if AB is equal to CD, okay, then I can say OP is equal to OQ. If the chords are equal, then the distance of those chords from the center are also equal. Clear, children? Right. So now the next point is the chords of a circle equidistance from the center of the circle are equal. Now it's a converse case of what actually you learned in the previous statement. If I have a circle over here and in the beginning only, I know that the distance of the chord AB as well as the distance of the chord CD from the center of the circle. Okay, that is I'm just calling this one as P and Q. Clear? So here I can say that the two chords AB and CD are at equal distance from the center, in the sense if OP is equal to OQ, then they must be equal in length. Then AB is equal to CD. It is just a converse statement of whatever you have learned over here. Clear, children? Now let us study the next point. If two chords or arcs of the same circle subtend equal angles at the center, they are equal in length. Clear? So here I have a circle and a chord or an arc. Okay, AB is a arc over here. If I join this one, that becomes a chord. Clear? If I join AB, becomes a chord. Okay, the circle subtend equal angles at the center. Though subtend means what? Meaning of the subtending means what? Forming. Clear? So now here I have another arc CD. Okay, or if I just draw this one, it becomes a chord CD. Whenever I'm having two chords here, and if they are forming equal angles at the center, this is the angle subtended by arc or chord CD at the center, and this is the angle subtended by the arc or chord CD, AB at the center. Clear, children? So here I can say that if angle COD is equal to angle AOB, then arc CD is equal to arc AB, or chord CD is equal to chord AB. Clear, children? The angles are equal, then the chords or arcs are equal. Very simple. Now the converse statement. If the two arcs or the chords of a circle are equal, they subtend equal angles at the center. Very simple. The converse statement. Over here I am saying that in the beginning only I know that the chord AB is equal to the chord CD. Clear? And this is the center. This is the angle subtended by the chord CD at the center, and this is the angle subtended by chord AB at the center. Clear? Is it clear? So here it says that if arc or the chord AB is equal to arc or the chord CD, then the angle subtended by AOB is equal to angle COD. These are the angles subtended by the arc or the chord AB at the center. This is the angle subtended by arc or the chord CD at the center. Clear, children? Again, both of them are converse statement. Now, see the next one. The ratio between the lengths of the arcs or the chords is equal to the angle subtended by them at the center. In the sense, very simple, children, seems to be very difficult, but if you understand the meaning of these statements, they are very simple. So now this is the center of the circle. Suppose if I have an arc over here, look at this, A, B, I'm just calling this as AB, and this is another arc CD I am going to take, and this is the angle subtended by the arc AB at the center, and this is the angle subtended by arc CD at the center. Clear, children? The ratio between the arcs or the chords, in the sense arc AB by arc CD is equal to angle subtended by, ratio between the angle subtended by these arcs at the center. What is the angle subtended by the arc AB at the center? It is AOB. So this will be equal to AOB by COD. Clear, children? Okay, so that is the meaning of the statement COD. This is again equal to chord AB by chord CD. Clear, children? So means what? The ratio between the arcs or the chords is equal to the ratio between the angles subtended by them at the center. Clear? All of you, yes or no? Next one is, look at this, the angle subtended by a side of an inscribed regular polygon at the center of the circle is given by the formula 360 by n. What is the meaning of this? Okay, now pay attention, children. So here I have a circle. Okay, whenever a regular polygon is inscribed, you know what you mean by regular polygon. Suppose if I am inscribing a regular pentagon, how do I get to know it's a regular pentagon? All sides are equal to each other. So if I draw a angle from the sides of this pentagon at the center, okay, so this is called a central angle, and this one is given by the formula 360 degree divided by n. Here it is 5, so it is going to be 72 degree. Clear, children? So suppose if I am inscribing a regular quadrilateral at the center, in the sense what? Okay, if I am inscribing a regular quadrilateral in a circle, so the angle subtended by the sides of the quadrilateral, regular quadrilateral, in the sense it is nothing but a square, so is given by the formula 360 by n. So for the quadrilateral, it is going to be 360 degree divided by 4, that is going to be 90. Very simple. These all are the concept what actually you learnt in your 9th standard. Clear, children? Okay, now let us move to the 10th standard concept. All these statements, all these theorems are the very basic things to tackle each and every problem of the exercise. You need to know the statement of these theorems. Also, if you know this is not sufficient, you must know when to apply, where to apply, and in which kind of problems you need to apply these theorems and statements. Clear, children? Right. So now let us start with the theorems which we have in the chapter Circles of Class 10 Standard ICSE. Actually speaking, very important thing I would like to say, first of all, I'm just calling this as theorem number 1, but whenever you are solving the problems and giving the reason as theorems, you are not advised to write the theorem numbers. You are always advised to write the statement of the theorems as the reason. If you write statement of the theorem, that is the only step you get marks. If you just write theorem number 1, theorem number 2, theorem number 9 and all, you don't get marks in ICSE board exam. Keep that in mind. Clear, children? Right. So now let us see the first statement. The angle which an arc of a circle subtends at the center is double that which is subtended at any point on the remaining part of the circumference. So meaning of this statement is, suppose if I have a circle, okay, angle subtended by an arc at the center, Okay, angle subtended by an arc at the center is twice the angle subtended by same arc in the same segment. So if this angle is x, this angle is going to be 2x. That is the meaning of the statement. Clear? I can rewrite the statement as angle subtended at the center of the circle is twice the angle subtended by the same arc in the same segment. Clear, children? I'll show you an example over here. See, for example, here is a circle and this is the center O I'm calling. If this is the angle subtended by the arc AB at the center and this is the angle subtended by the same arc in the same segment. So if this angle is going to be 30 degree, then this angle is going to be 60 degree. Very, very simple. Clear, children? Suppose if I have one more circle over here and angle subtended by the arc CD at the center, arc CD at the center O is 100 degree. Can you guess what is the angle subtended by the same arc in the same segment, children? Can you guess? Any guess over here? Yes, you are getting it right, children. This is going to be 50 degree. Is it clear, children? Yes or no? Right. So now let us go ahead with the second theorem, that is nothing but angles in the same segment of a circle are equal. Very, very simple statement, children. Right. So now look at this. This is the circle what I have and this is the center of the circle. Now if I am drawing, look at this, very simple. This is the angle in the segment. Clear? AB is going to be one of the angle in the segment. Suppose if I draw one more angle in the same segment by the same arc. Okay, so look at this. This is one more angle in the same segment by the same arc. Clear? Right. So I just call this as C and D. Right. So here I can say angle ACB is equal to ADB. Why? Because they are the angles in the same segment. Clear, children? Right. So basically, how can I say this one? Proofs of any of these theorems are not a part of your syllabus, but just, okay, you must know. Say for example, this is the angle formed by an arc AB at the center. Suppose if this angle is 60 degree. Now, can you tell me what is the value of this angle, children? Can you tell me what is the value of this angle? Yes, this is going to be 30 degree, correct? So, can you tell me what is the value of this angle? This angle is also, ADB is also subtended by the same chord in the same segment, right? This also should be half of 60 degree, correct? So, this is also going to be 30 degree. So, can I say, here if you compare, can I say this angle and this angle are equal to each other? Are they not the angles in the same segment? Yes, they are angles in the same segment. That is the meaning of this statement and that's the meaning of this theorem. Angles in the same segment are equal to each other. Clear? So now let us move to the theorem number 3. Clear? Theorem number 3 says that the angle in a semicircle is a right angle. So you know what is the meaning of semicircle. Semicircle is nothing but part of a circle divided by a diameter. Clear, children? Right. Whenever a diameter is drawn, diameter divides the circle into two equal parts and each of them are called as semicircles. Now this is nothing but the diameter. Clear? This is the center of the circle. AB is the diameter of the circle. Clear? Okay, so now can you tell me what is the value of this angle? This is a straight line. This is supposed to be 180 degree. Okay, and I will draw a angle, okay, in the same segment like this. So tell me, apply the theorem number 1 and tell me what is the value of this angle. It should be half of 180, right? So that means that it is supposed to be 90 degree. So if I draw one more angle over here, that is also going to be half of 180 degree. That is also going to be 90 degree. Clear, children? So what are these? Angle C and D are nothing but the angles in the same segment. Clear? So that is the meaning that angle in the same segment are right angles. That is 90 degree. ACB as well as ADB. Both of them are 90 degree. That is the meaning of third statement. Okay, third theorem. Clear, children? So now let us move to the theorem number 4. Theorem number 4. Here it says that opposite angles of a cyclic quadrilateral are supplementary. So what is the meaning of cyclic quadrilateral? You need to understand. Okay, so I am drawing a quadrilateral inside a circle such a way that all the four vertices of the quadrilateral are lying on the circumference of the circle. Then such kind of a quadrilateral is called as a cyclic quadrilateral, inscribed in a circle. Any quadrilateral or any polygon for that matter is said to be inscribed in a circle only if the vertices of that polygon lie on the circumference of the circle. Then only I am calling such kind of polygon as inscribed polygon. Okay, if it is a inscribed quadrilateral, then I'm calling it as a cyclic quadrilateral. So very basic things I told you in the beginning, also in other videos also. Whenever you are naming a quadrilateral or any polygon for that matter, always you should name either in the clockwise direction or you should name either in the anti-clockwise direction. Clear, children? So now can you tell me what are the opposite angles of this quadrilateral? Yes, angle A and angle C are the opposite angles of the cyclic quadrilateral ABCD. Clear, children? So it says that angle A plus of angle C is equal to 180 degree. Also angle B plus of angle D is equal to 180 degree. So that means what? Opposite angles of the cyclic quadrilateral are supplementary. What is the meaning of supplementary? Added up to 90 degree. Clear? Sorry, 180 degree. Added up to 180 degree. Complementary means adding up to 90 degree. Is that clear, children? Suppose if I have a quadrilateral over here and I am drawing a quadrilateral over here inside a circle ABCD. If this angle is 80 degree, can you tell me how much is this angle? This angle is going to be 100 degree because they both are nothing but the opposite angles and they should add up to 180 degree. Is that clear, children? If this angle is 110 degree, can you guess the value of this angle, children? This is going to be 70 degree because they should add up to 180 degree. Isn't it clear, children? Yes or no? Very simple, very simple, very easy. Clear? Right. So now let us go to theorem number 5. So what is the theorem number 5? Exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Right. So now I have a circle. Then I'm inscribing a quadrilateral in it. That's why the inscribed quadrilateral is called as a cyclic quadrilateral. So what is the meaning of exterior angle of a cyclic quadrilateral? Now when I extend this side of the quadrilateral to E, so this angle so called exterior angle. Clear? The angle which is found outside the cyclic quadrilateral is nothing but exterior angle of the cyclic quadrilateral will be equal to interior opposite angle. This is interior angle and opposite angle. Clear, children? So means what? I can say that angle CBE is equal to angle D. Clear, children? Yes or no? Correct. Okay. Why it is so? Why they are equal to each other? See, I'll just show you a simple example. Right. So this is a circle and a cyclic quadrilateral. Clear? So this is the exterior angle of a cyclic quadrilateral. A, B, C and D, and I'm calling this as E. Now tell me if a value of this angle is going to be 100 degree. Right. So what is going to be this angle? Please can you tell me? This is going to be 80 degree because these two are linear pair. Right. So now in the previous theorem we learned that opposite angles of the cyclic quadrilateral are supplement of each other. Clear? So means what? Angle B plus angle D is equal to 180 degree. Out of that, angle B is 80 degree. Then how much is going to be angle D? Can you tell me? This is going to be 100 degree. So can I say that exterior angle of a cyclic quadrilateral is equal to interior opposite angle? See, this is also 100 degree I got and this is also 100 degree I got. Yes or no, children? Yes or no? Yes. These are the very basic theorems on which the complete chapter of circle depends upon. Clear, children? This is about the first episode. In the next episode, we are going to take up the exercise, that is the first exercise, from which we are going to selecting some problems and we are applying these theorems to solve those problems. Till then, take care, keep working. Bye bye.